So today I'm joined by Elko Bergman. He's the Chief Business Officer for a company called Saras Micro Devices. Is that correct?
That's correct.
Okay.
Good morning.
Thank you for coming in today. Now you make a range of passive devices for embedding into substrates. Can you give our viewers a quick overview of the products that you make?
Yes. So we're an emerging company, and what we're developing is integrated passive modules to help enable 3D power delivery in advanced AI processor accelerator type devices. And more specifically, we're leveraging our capacitive and our inductive technologies to make it possible to do embedded integrated voltage regulation inside the package substrate.
Really? Okay. So, I mean, it's much better to do it in a packaged form than to try and do it with individual passive devices, obviously. Can you tell us what the advantages are there?
Yeah, so by creating these integrated modules, we can custom design the module for the customer application. So we can have multiple capacitive domains, inductors, et cetera, that are aligned with where they're required under the die. And then we deliver those components fully tested. So compared to doing discrete component embedding into a substrate, you now take the number of embedding operations from many to one or a few, right, which significantly helps improve the substrate manufacturing yields. Okay. And of course, by bringing it into the package in the first place, we're addressing the resistive losses with the power conversion that's now happening on the system board outside of the package.
Right. Great. So are you able to reduce the amount of power that's coming in, or what benefits does that bring?
Yeah, so today if you look at a typical system board, most of the active components, the memory, the logic has all been integrated into a large single package through 2.5 3D silicon integration. And so the system board consists heavily of all the voltage, power delivery voltage conversion. And for these large devices that are running at very high power but low core voltages, that means very high amounts of amps, 1,000 amps plus, need to be delivered, right, into the package. And there's a lot of resistive losses associated with that. So the industry direction is to try and bring at least some of that voltage conversion closer to the load die, such as having it embedded into the package or directly underneath the package, so that you can come in with higher voltage and thus lower current, which has a big impact on the IR losses.
Absolutely. What about thermal issues? I mean, because obviously with the amount of increased functionality that's getting built into these devices now, the thermal excursions are getting harder and harder to manage.
Exactly. It's a very good point. And when you do voltage conversion, there is some thermal load associated with that. And already these devices are being limited by how much they can dissipate. So we do have to be careful there. And there will be an optimization between how much conversion you can do inside the package versus outside, and what the gain in efficiency is versus the potential loss in thermal. So, but we believe that certainly for some of the lower input voltages, there's more of a gain to be had in terms of efficiency, and there's a net benefit to the processor supplier.
Right. Okay. So, typically, what sort of applications are you putting this into just now?
Yeah. So the initial customers we're targeting are the AI processor accelerator, GPU, CPU type companies, as well as some of these specialized accelerators, as well as the switch manufacturers. So the companies that are making these very large multi-die integration devices and that are running at, on the most advanced process nodes, 5-3 nanometers, low core voltages, high power.
Okay, interesting. Now, just finally, Elko, as I mentioned earlier, there's a move towards employing other substrates, gallium nitride, glass-based substrates. Would your device be able to be embedded into these types
So
of
for the
environments?
packaged substrates, you're correct. You have organic packaged substrates really dominating today, but there is a lot of industry interest in having a glass core in that substrate instead of organic.
Right.
And our components would be just as easily embeddable in a glass core substrate as they would be in an organic core substrate.
Great. Okay. So, are you based? Where are you based? Are you based here in the valley?
I personally am based here in Silicon Valley because the majority of the customer base is here, but our company is headquartered in Chandler, Arizona.
Okay.
And we also have an R&D site in Atlanta. The company actually started originally in Atlanta, so thus the R&D team, but we're setting up our manufacturing operation in Chandler.
Great. Excellent. Well, certainly an interesting product, and I want to thank you for coming in and telling us about it today.
Thank you for the opportunity. Enjoy your time at Semicon.
Thank you.